The goal of this exercise is to familiarize ourselves with the transpose of a matrix, as well as find a suitable definition for the transpose of the product. Can we write the transpose of the product as a product of the transposees? And when we do this, how is it possible? Under what stipulations? How should the end goal look like? These are all questions we can ask. Let us now try to find a suitable definition for what the transpose should be in terms of this product, of course. So if I start with this set of multiplication of matrices, we know already that matrices are linear maps. For example, A is a linear map that takes M as input and it outputs, let's say, N as output. When I say outputs N, I mean an N-dimensional vector. And the same thing when I say input. And then, in order for this to be well-defined, I need this B to receive this outputted vector N as input and output anything else later. Same logic follows when you look at the last multiplication here. It has to receive a p-dimensional vector as input, and it can return anything as output. This is really not of great interest to us. Okay, now we would like to transpose this somehow. Let's perhaps look at the transposes of each matrix separately. The transpose of an M times N matrix is N times M. Here this is P times N. With C this is just Q times P. Simply because you usually have a matrix that looks like this. Wait, this is a square. Not all matrices have to be square. This is N, say this is M. And then if you flip it, okay, that's good. Maybe I should. I should put it to the side here. So then I get M times N instead of N times M. So this is interesting. This is really what happens when we transpose. A matrix. So this is a matrix, you know what I mean? Good. Then I ask the following question. How can I represent a suitable, how can I make a proper multiplication of these three items? I claim there's only one way to do it. You should be able to see it by now. And we will follow the same logic that we applied here. The idea is to always follow, output, input, output, input. You have to be careful with this. So if I start with A transpose, it's N and then M. What do I link my M to? I don't know. There's nothing I can link this output to. Then probably this A transpose should be on the edge. And the edge on the right, I mean, because there's nothing I can link. There's no map which takes M as input. And this is why I put it to the rightmost part. Okay, what about B transpose? Okay, this looks nice because the output of B transpose would then be the input of A transpose. So this is well defined. And then the other one fits very, very nicely, I think. in the full picture, and you have the correspondence of output and input. This seems like a very fair and suitable way to define what A transpose of the product should be. And if you really give it a good look, this is the only way you could define the transpose of the product in terms of the product of the transposes. This is the only way you can multiply the three transposes in one expression. I don't like this word, transposes. Anyway, I think it's wrong. Perhaps there's transposi, maybe. I'm not sure. You see how they link together in harmony? And in fact, this is the only way you can link them. There's no other way you can link them. I think this is obvious just from how I presented it, but there is practically no other way you could define a transpose in this case, such that the multiplication of matrices is well defined. And with this, I conclude the exercise.